Yay! Today is Friday, December the 4th, 2020, and today we're going to continue learning to use patterns to multiply. We're going to kind of do a review of what we've already learned this week about 2s, 5s, and 9s as factors. So again, we're going to be looking for those patterns. What patterns can help us remember multiplication facts for 2s, 5s, and 9s. So our lesson objective for today is I am learning to use patterns to find products with factors of 2, 5, and 9. The purpose for this is for us to know that multiplication is the same as repeated addition. We can use arrays, groups, things like that we've already learned. And today we're going to be looking for those patterns again to help us with multiplication. What might you skip count by? What things come in groups of 5? So think about what you could use for skip counting in a real world situation that might work. And then think of things that come in groups of 5. What comes in groups of 5 that we could just use basic multiplication facts or skip counting to help us with those patterns? So let's look at this particular problem. How many fingers are there on 3 hands? What is a quick way for us to figure out how many fingers are on 3 hands? Yes, I hope you're saying skip counting by 5, skip counting by 3s, because you remember we can use that commutative property and help us to do it that way. We can change it and flip it around to get our answer. So there's many ways to get the answer here. I can draw an array, I can do groups, but I can also look for that patterns of counting, skip counting by 5, which would make it very easy for me to do. So one way is to count on your fingers by skip counting. So let's count on our fingers. We have, if we're going to be counting 5 by 5s, we're going to do that 3 times. So 5, 10, 15. So skip counting allows me to get the answer quickly when skip counting by my 5s. Which operation did you use to count your fingers? Basically, I use skip counting. It's just like repeated addition. It's saying 5 plus 5 plus 5. It's another name for repeated addition and multiplication. So we're able to use that skip counting method, which is the same as repeated addition, those of you who really like the repeated addition strategy. Remember, we had a vocabulary word this week called multiple. And remember, a multiple is a number. It is I'm sorry, I can't even talk this morning. A multiple of a number is the product of that number and any other whole number. So if I were to say that 3 times 5 is 15, 15 is a multiple of 3 and 5, because when I multiply those, I get 15. So it means that it is a multiple of both 3 and 5. So we're going to look at those factors and say, okay, if I multiply 3 times 5, I get 15, so that it's definitely a multiple of the two numbers, of the two factors. What pattern did you notice about the ones digit of the multiples of 5? So I want you to think about what we looked at yesterday when we were, not yesterday, it was actually Wednesday, because we were looking at the patterns for 2s and 5s. What patterns did you notice about the ones digit in the multiples of 5? Now remember, we talked about this. We talked about what we saw. And all numbers that are multiples of 5 end in 2 different digits. And I'm hoping that you're remembering that any multiple of 5 is going to end in either 0 or 5. So let's think about that. Let's count those numbers. Let's count by our 5s and see what every number we say ends in. So let's start out with 5. 10, 15, 20. Every one of those I just said ends in either 0 or 5. So that is a pattern that we notice when we're looking at multiples of 5. So if a number ends in 0 or 5, then we know immediately that it's a multiple of 5. What multiples of 2 follow a pattern? They follow a pattern as well. So on a piece of paper, draw a pair of eyes and write 1 times 2. And then I want you to draw a second pair of eyes. What number sentence should you write? If you drew 7 more pair of eyes, and write the multiplication sentence. What are the multiples of 2 up to 18? So let's think about that. Let's go ahead and do that skip counting like we talked about. After you draw your eyes, you're going to be able to skip count, which is again like repeated addition, to get that answer. So we're going to look for multiples of 2 up to the number 18. So multiples of 2 are going to be 2, 4, 6, 8, 10, 12, 14, 16, 18. Was there a pattern for those multiples? Now remember, we found the pattern this week. Who remembers what the pattern for this week for 2's was? Yes, they're all even numbers. They're all even numbers. The pattern for 2's is if the number is an even number, if the last digit ends in 0, 2, 4, 6, or 8, then it's going to be an even number and it's going to be a multiple of 2. I can multiply 2 times another number and get the answer. So what we're going to do, and I know I have group discussion there, and I would like for you, if you've got somebody at home that you can talk to about it, let's look at this particular situation. Riley calculates 69 times 2. Now I know we've not done 2-digit times 1-digit numbers, but we're looking for patterns and we're thinking about some of those thoughts that we already know about 2's, 5's, and 9's. Her answer is 129. How do you know without multiplying that Riley's answer is incorrect? So let's think back about what we know about those patterns of multiples of 2. How do we know without even multiplying that Riley's answer is incorrect? So go ahead and pause your video. Talk to someone there at home. How do we know, based on what you already know about multiples of 2, how do we know without multiplying that Riley's answer is incorrect? So pause your video and see what you can come up with. Well, first of all, because we know all multiples of 2 end in an even number, they either end in 0, 2, 4, 6, or 8, we know immediately that Riley's answer is incorrect because her answer ends in 9, an uneven number. It's odd. It's an odd number. So she is not correct because her answer does not end in 0, 2, 4, 6, or 8. It has to end in those numbers to be an even number. So the ones digit must be an even number. Now, before we move on, I've been thinking a lot about Christmas. You know, Miss Bays loves Christmas. And I know that you're studying some traditions around the world. Well, one of the traditions that I do at my house is every year my boys get a new ornament. And my boys are getting older. They're 22 and one's going to be 17 in a few weeks. So I don't care that they're getting older. I still do this tradition and I'll probably do it until Christmas is over for us. I will give them ornaments every year to put on the tree, something new, something that has happened to them that year that's been important to them, something exciting. Like this year, my son is got engaged, so I made an ornament with him and his fiance on it. So I always do something fun that's happened to them that year. And Waylon got to go to prom the first time this year, and he got to do a homecoming dance for the first time. So, of course, I made an ornament for him that had something about his dance that he went to. So, I always do something special on an ornament each year. In the message box for the lesson, I want you to tell me what I do for my boys each year for them to put on the tree, and it's a special ornament. So make sure you put that comment in there so that I know you've watched my video. All right, so let's move on. You all have access to hundreds charts. You have one on your virtual manipulative slide. I want sometime later today for you to just get some practice and use that hundreds chart. I want you to put a triangle around all multiples of 9. What patterns do you see with multiples of 9? And how can you use that to know if 135 is a multiple of 9? Now, that's a big number. We don't usually multiply past 100 because we are required to multiply within 100. Okay? But if we're learning to find those patterns, it's going to allow us to be able to find whether numbers that are greater than 100 are multiples of 9. So I want you to pull up on the virtual manipulative slide, and I'll put that up here for you. You have a hundreds chart right down here at the bottom. It's kind of on the floor. So if you click on that, you'll be able to pull up that hundreds chart. I want you to, you can actually pause the video here on this page whenever you get ready to do it so that you can look at that to see what the instructions are, but see what kind of patterns you find. And on Monday, we'll talk a little bit more about that to see what patterns you were able to find. But you can use that hundreds chart there on the virtual manipulative slide, which is located in our classroom on important information, or even in my on the web page where our classroom is located. So you can visit there to pull up that chart. That's all I have for you today. What I'm going to have for you to do as an assignment is your problem of the day. And then yesterday we did IXL F3 and F6. Today we're going to do F10, which is multiplying by 9. So make sure that you choose the one that is multiplying by 9. If you completed this assignment last year for any reason or did it earlier this year just to be playing around with IXL, you have to do the assignment again because it will not show up on my screen as complete. So you must complete it again, even if it looks like you've already completed it. Today we're going to be doing Fun Friday, and I'm going to have an activity for math. And Miss O'Brien's going to be doing an activity for social studies. So you get to choose which room that you go to at 12 o'clock. I hope to see you there, and everybody have a great day.